So before we get into the lesson, I just want to talk about what's on the quiz that is being handed out today. Lesson 2.1, like if you have an inequality like x greater than 2 or something like that. So a one variable inequality, you'd have to sketch, in this case, a dotted vertical line. And you would shade to the right, greater than. So that would be your answer, would be the graph. Find the distance, so definitely know the distance formula. I would say you need to memorize that distance formula. x2 minus x1, y2 minus y1 squared. Midpoint, you should definitely memorize the midpoint formula. X1 plus x sub 2, you average the x's, divide by 2. Average the y's, add them up, divide by 2. Make a table of values and sketch an unfamiliar graph. So you might not know how to graph a certain graph. Find the x and y intercept. That's always a big tip when you make a table of values or when you find something. For example, if you are going to find, let's try to graph this one. So y equals negative x squared plus 1. So if I go to, let me get some graph paper here real quick. Sorry. Okay. There we are. Okay, so let's plug in some points. If we don't know what this graph looks like, that's okay. You might just want to, you could plug in, find the y-intercept by plugging in x equals 0. So do that, that would be y equals negative 0 squared plus 1, which is 1. So 0, 1 is a point on this graph. I already have 1 point. Plug in y equals 0 to find the x-intercept. Plug in y equals 0, so that'll be 0 equals negative x squared plus 1. I'm going to add x squared to both sides, so x squared equals 1. Square root both sides, don't forget, plus or minus. X equals plus or minus 1. So I have a point there at 1 and negative 1 for my x-intercepts. We could just make a point, a table and plug in a few other values. So I've already plugged in negative 1, 0, and 1, essentially, because I have those 3 points. So maybe something a little bigger than 1, a little smaller than negative 1. I'm going to plug in 2 and negative 2, maybe 3 and negative 3 if I need them, which I might. So let's plug in 2 here. Now here's the key. You plug in with parentheses, so that negative is not being squared, only the x is. So if I plug in, it's going to be negative 2 squared plus 1. Well, if you do order of operations there, that's 2 squared, which is 4, and it's negative 4, because the negative's on the outside. It doesn't get squared. So negative 4 plus 1 is negative 3. So there should be a point 2, negative 3, right there. And again, let's plug in this one. Now be careful. This is, again, you have to plug in with parentheses here. So it's very important. If there's a negative in front, in this case, only the x is being squared, not the negative. There's no parentheses around the negative. So that's going to stay out there. So this is going to be negative 2 squared, which is positive 4. But there's a negative in front, so it's going to be negative 4 plus 1, which is negative 3 also. So it's actually the same value, negative 2, negative 3. You probably have enough points. If I plugged in 3, I'm guessing it's going to be too low. So it'll be negative 9 plus 1 is negative 8. And my graph doesn't go quite down to negative 8. But if it did, it'd be 3, negative, I think it goes down to negative, somewhere down there-ish. And I'm sure you'd get that same value over here. It's a very symmetric graph. So then you could graph, it looks like a parabola. That's not a surprise. You should probably know an x squared graph is going to be a parabola shape. You don't know how to graph these the shortcut way, so the way we do it is we start with the x and y intercepts, and then we just plug in a few x values until we have enough points to go, yeah, I think I know the shape of this graph. I can probably draw it now. That'll be what your quiz is. Going back to yesterday's lesson just for a minute,
We could derive the circle formula if we used the distance formula. So remember distance formula, d, in this case r, so r equals the square root of, it would be x2 minus x1, so that would be x minus h squared, plus the formula is y2 minus y1, so y minus k squared. And it takes one more step, basically, to derive this formula. If you square both sides, you get r squared equals x minus h squared plus y minus k squared. So that's the center of your circle. HK is the center of your circle. That's the formula or the equation for your circle. So that's how we can derive that formula. You don't have to do that, but that's how you derive it. Just double check you're getting yesterday. So if you, like, I would probably write out the ordered pair here. This is 2 comma negative 3. So my h is 2, my k is negative 3. So if you think about that formula, it'd be x minus h. So x minus 2. So I know it's one of these guys. It's not one of those. Y minus k, so y minus negative 3 is actually y plus 3. It's one of those. That doesn't help me. The radius is 3. R equals 3, it looks like. So the formula is r squared, so that has to be 9, so it has to be B. Try to stop this one. Try it for a second. Again, if I'm doing this, I'm going to label the ordered pair negative 4 comma negative 2. So it's going to be x minus h, x minus negative 4, which is x plus 4, y minus negative 2, which is y plus 2. The radius is 2, which means the radius squared is 4. It's got to be B. Working backwards, plugging into the formula. So that formula we just used, it would be x minus h, which is negative 1, which is boom, boom, plus 1, plus y minus k, which is 4, equals r squared, which is 25. So it's not bad. Again, you're just plugging that formula we just derived a minute ago. Okay, so today's lesson, which deals with completing the square and symmetry. So first, let's complete the square. What we're trying to do is get things, we really like this form. This is the equation of a circle. It's the one we just derived. This may or may not look like a circle to you. It does look like it could be a circle, but you have to kind of change the form of this. So to do that, let's do it on this one. So the steps I'm going to do, I'm going to show off the left. So the steps, the first step is group the x's and the y's together with the constant on the other side. It's really sloppy, sorry. Okay, so you want to move this constant over. We did that with complete the square before, so that's pretty normal. But you also want to group the x's. I'm going to do this step in one step. I think it's pretty doable. So x squared plus 4x. I even know what my next step is going to be, so I'm putting plus blank. And then plus y squared minus 6y plus blank equals, if I add 12 to both sides, that equals 12 plus blank plus blank. So I've got to figure out what I'm going to add to this side. So we do the basic complete square. Remember complete square with this, you take half of 4 and square it. Half of 4 is 2, 2 squared is 4. So I'm going to add 4 to both sides here. Okay, so then this one, half of negative 6 is negative 3. Negative 3 squared is positive 9. It's always going to be a positive number you're adding, so I'm adding 9 to both sides. So I've basically completed the square on both sides. Let me just kind of put it in the right form. So I guess that second step I didn't write, but you add half the middle term squared, half the middle term squared to both sides. Third step of completing square, and since you've done this before, this is actually easier, is you're just going to factor, simplify both sides really, kind of get it a little nicer. So this should be a perfect square. That's why we added that certain amount. It's got to be plus because that's plus and plus. The square root of 4 is 2, so it's going to be x plus 2 squared. This also should be a perfect square because we added that perfect amount. There's a minus sign there, so it's going to be minus square root of 9 is 3. And then we have 13 plus 12 is 25. If they went to the next step, identify the center and radius of this one. The center would be at HK would be -2, 3. The radius would be 5. And you could draw it from there if you needed to draw it as well. So go ahead and try it. Again, we're going to do this. Most of my students find this, if they've got the other complete square stuff, this is a piece of cake. In fact, this isn't that difficult of a problem. X squared minus 8x is a minus plus blank plus y squared plus 10y plus blank equals positive 9 when I add 9 to both sides. So I need to add, let's see, half this middle term squared, half of 8 is 4, 4 squared is 16, add 16. And half of 10 is 5, 5 squared is 25, so I'm going to add 25. So this should be a perfect square. Minus, because of the minus, 4 is the square root of 16. Y plus, square root of 25 is 5. Equals 25 plus 25 is 50. And if they ask for the center and the radius, it would be positive 4, negative 5, so HK. And the radius is the square root of 50. You might be able to simplify that. So that's probably what, 5 root 2. If you want to simplify, that would be great. Okay, so let's look at symmetry for a second. So there are 3 different types of symmetry. You have to do a test. Any function you're testing for symmetry, you have to do all 3 tests on the same function. So the first test is symmetry with respect to y-axis. Let me just show you what that looks like first. So let me go to, I think I have. There we go. Okay, so symmetry with respect to this function, looks like a y equals x squared function, is symmetrical with the, do you see how this point, if I were able to like reflect that point across the y-axis, it actually moves to -1, 1. That graph is completely symmetrical with itself, right? So it's almost like you could fold the right hand of the graph over the y-axis and it would land exactly on the left-hand side of the graph. It's symmetrical with respect to the y-axis. It looks symmetrical with respect to the y-axis. Y-axis is kind of your axis of symmetry there. It kind of divides that parabola exactly in half. So that's what it'll look like. But you can't just look at a function and go, well, I'm pretty sure it has symmetry of the y-axis. You have to prove it. So there's a test for that. So to prove it, you're going to do this test. So the test says you're going to plug in -x and see if it's the same function. Okay, so that's the test. So I'm going to take this function, y equals, instead of x squared plus 5, that's a squared, this is going to be -x. And so before you kind of see if it's the same function, I want to decide if this is always, think about the positive and negative of each term. So when you have a negative squared, is that always positive or always negative? That's going to be always positive. Square and negative, it's positive. So I'm going to write this as x squared plus 5 because it's always positive. I don't need to write a negative there. So this function transformed into this function, is that the same exact function? It is. Therefore, yes, this has y-axis symmetry. You don't have to know this, but if I were to graph this, the graph looks something like this. I moved up 5, and the graph looks like that. And you don't have to know the graph, but it is symmetrical to the y-axis. If you graphed it on the calculator, you would see it beautifully, that it is very symmetric. Let's try this one. So again, we're just going to plug in, everywhere there's an x, we're going to plug in -x. So y equals -x to the third minus 4. Before we decide if it's the same function, let's decide if that middle term there is kind of always positive or always negative. You have a negative number to a third to an odd power. Well, I think that's always going to be negative, right? It is. It's actually always negative. So
That's a different function than what we started with. So this says no y-axis symmetry. So we've only done one of the tests. It might have some other symmetry. Each function, you have to test all three tests, but that one does not have y-axis symmetry. In this one, let's plug in negative x, so y equals, and this one's kind of weird because it has two x's. So everywhere there's an x, even the second x there, I'm going to plug in a negative x. And so this term is negative x squared. That's actually a positive number all the time. Plus, that's a negative 3x all the time, and minus 7. Because of this, everything else is the same, but this changed. So this is no y-axis symmetry. Again, we may have to test for other symmetries, but no y-axis symmetry. Okay, the second test is symmetrical with the x-axis. So what a function might look like, just to kind of think visually here for a second, maybe this function would be symmetrical with the x-axis. It looks symmetrical anyway. We would have to do the test to be sure if it is symmetrical or not. So the test is plug in negative y every time you see a y. So let's try this one first. Oops. Okay, so everywhere there's a y, I'm going to plug in negative y. So negative y with parentheses here, I'm plugging in. And that actually, when you have a negative number squared, that's always y squared. It's always positive. That looks like the same function, so yes, this has x-axis symmetry. We have to test the other test to see if it has other symmetry, but it definitely has x-axis symmetry. Let's test this one. So x equals, kind of weird, absolute value negative y plus 1. So when you have a negative inside absolute value like that, I believe that will always be positive, right? That's the same, so yes, there is x-axis symmetry. And last one, so x equals the square root of negative y. Well, that definitely is not the same, right? That's not going to simplify to always positive or always negative. So that one is no x-axis symmetry. It might have some other symmetries, but it doesn't have x-axis symmetry. The last test for you, I'm going to show you a picture of what it looks like. Is this test? So this function has origin symmetry. So if you move it, we're kind of like, think about it as rotating this function 180 degrees around the origin, and it rotates onto itself. That negative 1 point rotates to 1, 1, like it's symmetrical with the origin. If you just were able to visually rotate it 180 degrees, it's the same function now. It didn't change at all. It's the same exact function. So that's what it looks like. The test is kind of interesting. It's actually plugging in a negative x and a negative y. So you're doing both. So like this function, you're seeing if it's the same. So it's really the same test every time, but just to plug in different values. So this would be negative y equals negative x to the third. And so on this one, definitely that one's always negative, right? And that one's always negative. And so you might at least at first go, wait a second, that's not the same function. But actually, it is. If you divide, if everything changes sign like this, the y changes to negative y, the x changes to negative x. The sign of everything changes. It's the same function. Because I can divide everything by negative 1, and now I have the same function. So that is the same function. So yes, this does have origin. It's called origin symmetry. Now we might have to test it to see if it has the other two, but it definitely has origin symmetry. This one we're plugging negative y. With parentheses, I'm plugging in negative x. With parentheses, I'm plugging in negative x. And so this term definitely changed. This term stays the same. It's still positive x squared. That term changed. This term stayed the same. Some terms changed, some terms did not change. This, it would be no origin symmetry. And the last, one more, the last one of this would be plug in negative y, plug in negative x. Everything changed. If you divide by negative 1, you get the same function. So yes, this has origin symmetry. If you look at a graph of this, you might know this graph. It looks like this. And you can see like this point's going to rotate around to be about there. Like it's very symmetric. You rotate around the origin and it'll be the same function. So let's do a test for all three for this one. So first let's do, so we're going to test all three here. So first let's do y-axis. So to do y-axis testing, we're going to plug in negative x. So negative x squared plus y squared equals 9. So this would be x squared, because that's always positive, plus y squared equals 9. That's the same function. So yes, it has y-axis symmetry. Plug in negative y, so x squared plus negative y squared equals 9. Well, negative squared is always positive, so x squared plus y squared equals 9. That passes the test. It's the same function. It has, let's see, x-axis symmetry as well. Wow, it has both. So I guess it's possible to have a function that has both. Let's just go ahead and check origin symmetry and see what happens. So you plug in both negative x and negative y. Simplify as in that term's always positive, that term's always positive. That's the same function. Yes, it has origin symmetry. And the reason for this is actually the graph of, can you tell? It's that function, or it's not really a function, it's an equation. I think the graph of this would look like something like this, roughly. It's a circle, right? And so a circle has y-axis symmetry. You can fold it over the y-axis, fold it over the x-axis, rotate it around the origin, and it has all three symmetries. So that's the only kind of shape I would think that has all three symmetries in one equation. That's your lesson.